Okay, so for example 9.1, we are told that we have a compact disc which has a radius of 0.060 meters, and it has an angular velocity here of 7,200 revolutions per minute, right? And yeah, this is just a basic setup of how it would look like, right? We have the angle here, a 90 degree angle here, and that's just the setup of it. Okay, so now the first part of the question is asking us for the CD's angular velocity in radians per second. So we're trying to look for angular velocity, and to do that, we know that so this is how much it spins. So anyway, to do that, we just need to convert the angular velocity in radians per second. So this in radians per second. So all we have to do is cancel out, convert the minutes to seconds, which we do here, a minute over seconds, and then we convert the revs into radians, which we know is right here, right? One revolution is basically equal to 2 pi, right? 2 pi radians, right? So then you do that, and then you get 754 radians per second. So that's for the first part of the question. The next part of the question wants to ask us for how much time is required for it to rotate through the 90 degrees. So how much time it takes for it to rotate through the 90 degrees. So for that to happen, we know that the change in the angle over the change in time, right? But knowing this equation, we also know that the change in this is going to equal to angular velocity, W, right? I didn't write that there. But knowing that this equation is like that, we know that the change in time, which is what we're trying to find, how much time is required, is equal to the change in the angle over the angular velocity, right? And we already have a lot of those things. We already have that the change in angle in radians, right, is going to be pi over half, which is the 90, right? And we have the angular velocity, which we found in the first part, 754. You do that, and you get your change in time as 2.1 meters per second. Milliseconds, sorry, 2.1 milliseconds. Right, we had it 2.1 times 10 to the negative third seconds, and we just converted it to milliseconds. So that's the second part. Now the third part is asking for the acceleration, I believe. Yeah, it's asking if it starts from rest and it reaches full speed in 4 seconds, what is the average angular acceleration? So now we know that the change in time is going to be 4 seconds from rest, and it reaches full speed in 4 seconds, right? We know this, and it's asking us for the angular acceleration. We know that the angular acceleration, which is this over here, is going to be equal to the change in time over the change in angular velocity over the change in time, right? We already have the angular velocity, and we already have the change in time, 754 radians per second. We got in the previous question over the change in time, which is 4 seconds. And this should give us 189 radians per second squared, which is the angular acceleration.